All right. So I'm going to present my screen for the warm-up. It is 5 questions today, but it's they're all questions that spiral in some things that I want you guys to practice. So I'm going to give you guys about 10 minutes on this one. It's a little bit longer. I want to give you guys the time to work on it and try out the questions. So, question 1 has some money. So talking about checking accounts, buying things, adding money to your, actually there's no adding money at all. So this girl's just spending all of her money, it seems. Number 2, we're dividing some fractions. Number 3, bringing out a ratio. Number 4, you're subtracting integers. So keep that in mind. Are you going to stay negative? You're going to go positive with number 4. And then number 5, we're listing prime numbers, numbers that can only be divided by 1 and itself. So go ahead and we'll take probably about 10 minutes to work on these 5 questions, okay? Go ahead and work, please. There's a lot of money for that. So she starts off with $456, and then she spends more than life on leaving.
She got a new iPhone for June 23. 75. Mhm. Unfortunately, I got a new iPhone, I gotta spend money. Mhm.
So blue circles. So just the blue circles compared to all of the circles. Yeah, so you add all of the circles together. All of the circles that you see.
Do we have a sign?
Kind of. We're gonna do some notes where you'll do some independent stuff. We'll do about 3 more minutes.
Had $456 in that. That's okay. There's a one, and I don't have all of the money. Yeah. Taylor is not there yet. That'll be the one. No. There's a green letter.
There we go. 1 more minute. Numbers that can only be divided by 1 and itself.
And that. Then how do you go about solving it? You can keep change what? Anyway. I mean, you can always find out if you look into the line, so maybe do that. If you think we're gonna have to.
They're probably listening to the story from this morning.
Okay.
Okay. Let's go ahead and review some of these. So number 1, Fiona has $456.98. Okay, so she starts off with that amount of money. She bought a new iPhone for $322.75, and she bought a new case for $53.02. Am I going to add or subtract that money from her total? Yoshi? Subtract. She also, on her way home, had to get gas, and she paid $65.32. Am I going to add or subtract that money from her account? Subtract again. So we got to do a lot of subtraction with our decimals and our money here. How could you make it easier?
First, add the things that you're subtracting that from, and then subtract that total.
You could, yeah. You could do both ways. You could add up the things that you need to subtract and subtract it from the total, or you can just do the separate steps of subtraction. I think I'm going to do all the subtraction just to show you guys that. So, let me get rid of this. All right, we can see it all right. So what was the first amount that we're subtracting? 300, what was the iPhone? I don't remember. $323 and how many cents? And 75 cents. So we're subtracting that first. That's the cost of her iPhone. What is 8 minus 5? 3. What is 9 minus 7? 2. Drop down your decimal. Remember, you always line up the decimals when you're subtracting decimals. What is 6 minus 3?
3.
5 minus 2?
3.
3. And 4 minus 3? How are we doing so far? Doing good? So we have $133.23 left in her bank account. And then she's buying another phone case, which was $52 and how many cents? Oh, $53.
2 cents.
Okay. $53.02. So we need to subtract that. What's 3 minus 2? 1. 2 minus 0? 2.
0.
Drop down your decimal. 3 minus 3 is 0. Can I do 3 minus 5?
You have to go to the
0.
Yeah, we have to borrow. The 1 becomes a 0. The 3 becomes a 13. What's 13 minus 5? 13 minus 5? Is 8. So now she has $80.21 left. She's really just spending all her money at once. And then she bought gas. How much was the gas? $65.32. So now we got to subtract the gas. $65.32. We got to do a lot of borrowing on this one, right?
Yeah.
None of these work. So we're going to start over here. The 8 becomes a 7. The 10 will become a 9. 12 will become an 11. And this 1 becomes an 11. What is 11 minus 2? 9. What is 11 minus 3? 8. Drop down your decimal. What's 9 minus 5? 4. And 7 minus 6? 1. How much money is left in this poor girl's account?
1.
$14.89.
Negative.
It's not negative. She didn't go negative quite yet. I'm sure she bought one more thing. She'd be in the negatives though. Which is not good. So there's number 1. Lots of subtracting there. And Charlie was right. You could have added together 323, 53, and 65 and subtracted it from your total. That would have been fine too. Did you guys that did that? I saw a couple of you guys do it. Did you get the right answer?
I did.
Close?
I did, but then I didn't mind.
Okay.
I got 13.9.
So we're all close. Our next one was 9 divided by 1/3. So we have the number 9. Dividing it by 1/3. We can do our skip change flip, but what do I need to do to our 9 first?
Did you double check the first one, the 3, 2, 3.5?
No, but
Is that was the right one?
no. But we're fine. We're past that. It's okay. We did
It
subtract.
might have been wrong, it might have been right.
I'm gonna trust that Jada was right when she told me. We'll be fine. What do I need to put under the 9? I heard some of you guys say it. A 1. Now, before we can divide, what are the letters I need to do? What's it called? Keep, change, flip. Keep the first one. Change, division, flip the second fraction. Keep 9 over 1 the same. What do I change division to? Multiplication. What do I flip 1/3? 3 over 1. Yeah, that's really how you say it. 3 over 1. We need to multiply straight across. 9 times 3 is 27. What's 1 times 1? 1. What's another way I can write 27 over 1?
1.
Just 27. There's our answer. 27. How'd you guys do on that? Good? Good?
I got it.
All right. Number 3
Good.
was the ratio of blue circles to the total number of circles. For those of you that got that far, how many blue circles were there? 3 blue. Compared to how many total circles?
3.
12. Good.
I simplified it.
Good. Yep, and we're not completely done. This is a correct ratio, but we need to simplify. What number goes into both 3 and 12? What number goes into both? Well, 1 does, but 3. 3 goes into both 3 and 12. What is 3 divided by 3? 1. Compared to 12 divided by 3 is 4. So our final ratio there is 1/4. Remember, you should simplify these. Just like you simplify a fraction, got to simplify your ratios as well. Yes, Charlie?
I got that one. I got 1 to 4, and I got 1/4.
Yeah, you can write ratios different ways. You can do 1 to 4, you can write 1/4, or you can write 1 to 4. There's 3 ways to write a ratio. You can do both, or all 3. Next one, number 4. What? 17 minus 23. This number is going to go into the negatives because 23 is bigger than 17. Now, I'm going to show my number line. Can you guys see the number line okay online? And you can use the process of like keep change, which changes it to an addition problem, or you can look at a number line. You start at the number 17. Okay. You start at the number 17, which is way over here. I know you can't see it. If I'm going to go subtract 23, am I going to go to the left or the right or the left? The left. We're going to go backwards 23 times. So you can count. All the way to 0 is 17, 18, 19, 20, 21, 22, 23. If I go backwards 23, what number do I end up at?
-6.
-6 is our answer.
I got that one.
That's it. I think number lines are probably one of the easier ways to do it. Just draw yourself a number line and count it out. If it's too big, remember you can do the keep change. Keep change. Keep the 17. Change that to a positive, and this becomes a -23. When you do that process of adding different signs, you do get -6 as well. Okay? Both ways work. And our last one, number 5, was to list the prime numbers between 2 and 20. You can include 2 if you want to, but what would be the next one? 3, because remember, a prime number is a number that can only be divided by 1 and itself. So 3 is a prime number. What's our next one? 5. Then 7. Not 9. What's next after 7? 11 is 1.
I said in between 2 and 10.
2 and 20.
Oh, 2 and 20?
Yep. 11. What's next after 11? 13. Any other ones?
17.
17 is 1. There's one more. 19. Those are the numbers that can only be divided by 1 and itself. Okay? Do they need me for anything? Okay, thanks. Cool. So that's our warm-up for the day. We don't really have an assignment, but we do have some notes that we're going to talk about. They're pretty simple. This week we're going to be doing order of operations, PEMDAS. So we're going to PEMDAS. Please excuse my dear Aunt Sally. It should be a little bit familiar. They do it in 5th grade, right? Sort of. Yep, we do a little bit of it. So we're going to start off today with exponents, just talking about what an exponent is and how to do the math behind an exponent. So on Google Classroom, there should be a new math assignment posted that is called Exponents, Notes, and Practice. Thank you. Should be new. Oh my gosh. There we go. Exponents, Notes, and Practice. Everybody has their own set of Google Slides, so you guys can open that up. And I think there's 6 slides total. I don't think it'll take us too long to go through this, and we'll be done with math after that. So I'm going to give you about 1 minute. Go ahead and get this pulled up, please. I'm going to erase what's behind me. Okay. All right. How are we doing? We'll be typing on slides 4 and 5.
Doing
Okay,
good.
good online. Everybody getting it pulled up? I think you guys are pretty like good at this now, getting everything
Yeah.
pulled up quickly and all that. We've been using it a lot, Alex. Quickly, very quickly. Okay, take about 30 seconds. All right. Exponents. I actually really like exponents. I think they're pretty fun. So in exponents, if we go to slide number 2, I'm not going to present it and make it big. Well, I guess I can right now. So slide number 2 talks about what an exponent even is. All exponents do is show you repeated multiplication, the amount of times that you're going to multiply something by itself. So this one right here, the way you say it is 4 to the third power. So 4 raised to the third power. You're going to take the number 4 and multiply it by itself 3 times. So if you look behind me, it would be like a 4 times 4 times 4. You take the number 4, multiply it 3 times. And then you just do the math. What is 4 times 4? 4 times 4 is 16. So we've used this 4 and this 4. And now we need to take 16, multiply it by 4. That's times 3. That's 4 times 3. 16 times 4 is 64. So when we take 4 to the third power and we multiply it out, our answer is 64. And we're done. You just multiply it that many times. Okay? The big number, the number that's being multiplied, is called the base. So the big number is the base. The exponent is the number that's smaller at the top on the right that's being multiplied together. Now, on the internet and writing these exponents on computers is not very easy to do. So a lot of the times when you see an exponent written on the computer, you're going to see it written like this: 4 caret 3. Because there's no way to write it easily on the computer. I copy and pasted those pictures. So it's not super easy to write. But when you see something that's 4 caret 3, it really means 4 raised to the third power. It's just very difficult to write it out like that. Does that make sense? Okay. Keep in mind that this caret just means it's an exponent instead. Okay. So let's look at some examples. On the next slide, we have quite a few examples here. We have 9 squared, or 9 raised to the second power. You're going to take the number 9, multiply it by itself twice. So 9 times 9, which is 81. The next one is what we just did, 4 to the third power, or 4 cubed, sometimes people will say. That means you're going to take the number 4, multiply it by itself 3 times. When you do that multiplication, you get 64. Our next one is 3 to the fourth power. You're going to take the number 3, multiply it by itself 4 times. 3 times 3 times 3 times 3. When you do that, you get 81. When you do all that math. And finally, 2 to the fifth power. Take the number 2, multiply it by itself 5 times. 2 times 2 times 2 times 2 times 2. And you get 32. Is this making a little bit of sense? Just lots of multiplication? Okay.
Yes.
We'll work on it. Okay. All right, let's do this chart. We're going to do this chart together, and then the next one you're going to do on your own. So this is what I mean by the example of, I'll zoom in a little bit, not being able to write an exponent. So on these ones where it says number, I wrote 2 caret 3. That means 2 raised to the third power. So on this one, the chart, basically we just need to fill out the different sections. The number means what our number is, 2 to the third power. Our base is the number that's being multiplied. What is the exponent here? How many times are we going to multiply it? How many times? Good. 2 raised to the third power. Good. 2 to the third power means the exponent is a 3. And then when you multiply it out, 2 times 2 times 2, you get 8. Okay, let's look at our next one. Am I going too quick or are we okay? You all right?
Okay.
Okay, I guess that's fine. So 3 raised to the second power, or 3 squared, is sometimes how it's said. What is the base? What is the number being multiplied? 3. And we're multiplying it together how many times? Twice. 3 raised to the second power, we're going to take the number 3, multiply it by itself 2 times. 3 times 3. And we know that 3 times 3 is 9 on that one. Okay. Any questions so far? How to type things out maybe? Are we good on that? Doing okay? I'm going to take that as a yes. Our next one, 5 raised to the 4th power. What is the base? What is the number being multiplied? Yoshi? 5. Good. How many times am I multiplying 5 together? 4 times. Now we need to do that math. I'll give you guys like 2 minutes. You need to do 5 times 5 times 5 times 5. Okay? Sometimes these take a little bit longer to do all the multiplication, but take that time. 5 times 5 times 5 times 5. Go for it.
I'm not gonna come check it right now. Not in the middle.
So far, everything you guys did is right.
I just multiple.
Hola, everybody.
What's up, Skylar?
Hola.
Hi. Go ahead and
Tell
pull up.
everyone I said hi.
They can hear you. Go ahead and pull up these notes and follow along with us from here, okay, bud? All right. Now, let's go over this 5 times 5 times 5 because I saw the most common mistakes with exponents is that you take the 5, that's the base, and you multiply it by 4, and you say that your answer is 20. What's wrong with that? Why is it not 20? Repeated multiplication. We need to multiply it multiple times. So we need to take 5 times 5. What is 5 times 5? 25. Multiply it by another 5. So we need to take 25 and multiply that by 5. What did you guys get? 125. Then we need to take 125 and multiply it by the last 5. What is 125 multiplied by 5? 625. So if you got 20, you maybe did 5 times 4. If you got, I can't think of another one. I don't know. How'd you get that one? Okay, maybe you just multiplied wrong. Yeah. So just keep in mind that it's repeated multiplication. You're not adding the numbers. You're not just doing 5 times 4. You got to multiply 5 4 times. Okay? So let's look at our next one. They give us the base and they give us the exponent. That's all the information we need. What is the base of this one? 6. So we take the 6. Then we need to do it raised to the power of 2, so the exponent. In order to do that, you hold the shift key and you type the number 6. That's where the little caret is. What's the exponent? What number are we multiplying? 2. So we have 6 raised to the second power. When we write that out in expanded notation, what am I going to write? 6?
6 times 6.
Okay. 6 times 6. And then we know this one easily. What is 6 times 6? 36. That was kind of a simple one, right? Now, let's look at our last one there. And then I'm going to have you guys work on the rest of the chart on your own. This one, they give us the base, but we don't know the exponent. How could we figure out the exponent? Good. We can look over here at the expanded notation and look at how many times they repeat it. How many 8s do you see there? 3. So our exponent is 3. 8 to the third power. So we need to type that as 8 caret 3. 8 raised to the third power. And then we got to do that multiplication. I'll do it behind me. 8 times 8 times 8. 8 times 8. 8 times 8. What is 8 times 8? Well, 8 times 8 first.
24.
64. And then we need to multiply that by our last 8, which is close. Not 502, it's 512. 6 times 8 is 48, plus 3 is 51, so 512 is your answer on this one. Did you guys get that one before I even got there? Some of you guys were done way before me. So that's kind of how you're going to finish up this chart. On the next slide, slide number 5, you guys have 5 of your own problems to do to finish the chart for 5 of those. I'm not going to review these answers at the end. I'm going to just have you guys turn in the notes when you're done and I can check it over and see what we need to review tomorrow before we do PEMDAS. But your goal, you guys have about 20 minutes until we have to go. I want you guys to finish the second chart on your own, where it says practice on your own. Okay, this is the chart you're going to finish up. Anybody have any questions about this?
Is there only 5?
Yeah, there's only 5. Just those ones. Once you finish, you can turn it in. If you're already done online, then you guys are able to head out, and that's fine. So finish it up, and you guys will be good to go. Once you're done,